Hey there, welcome back to our Revolution Games Academy. Now that we've learned how to manage background music, let's move into something more immersive. Implementing 3D spatial audio. This technique allows you to place sound within a 3D space, so it sounds like it's coming from specific locations in the game world. This creates a more immersive experience, making your game world feel dynamic and responsive. First, select the player game object. Now, let's make sure that our player object has an audio source component attached, with an audio clip assigned to it. Set the spatial blend to 1 to ensure the sound is fully 3D. This setting blends between 2D and 3D audio, with 0 being fully 2D and 1 being fully 3D. When the spatial blend is set to 1, fully 3D, Unity applies distance attenuation, meaning the further the listener is from the sound source, the quieter the sound becomes. Now, let's test it. Next, adjust the min distance to a value like 1 unit, which represents the distance at which the sound plays at full volume. You can fine-tune this to fit your needs, depending on how close you want the sound to be before it starts fading. The max distance controls the range at which the sound fades out, and you can set it to a value like 50 units to make sure the sound only fades after a reasonable distance. This will ensure the sound remains audible within the intended range of your scene. Fine-tune this based on your needs. Now, for the roll-off mode, the default logarithmic roll-off works well in most cases, but feel free to experiment with other options based on your preferences. The logarithmic roll-off makes the sound decrease in volume more naturally as the player moves away, which feels more realistic. Linear roll-off refers to a consistent proportional decrease in the volume of a sound as it moves away from the listener. In other words, the sound's volume decreases at a fixed rate over distance. Custom roll-off, on the other hand, allows for a more flexible, adjustable approach to how a sound's volume decreases over distance. With custom roll-off, the volume reduction can follow different patterns or curves based on the designer's needs. Additionally, Unity provides the Doppler effect, which simulates pitch changes based on the movement of sound sources relative to the listener. For instance, if a car passes by the player, the sound of the engine will change in pitch depending on whether the car is moving toward or away from the listener. You can adjust the Doppler level on the audio source, where setting it to 1 applies the typical Doppler effect and setting it to 0 disables it. You can observe the change in pitch when the car passes the listener. Another important property to adjust is spread. The spread value controls how much the sound is spread out across space. A spread of 0 means the sound is emitted in a single direction, while a higher spread, for example 180, makes the sound come from all directions, simulating a wider source like a large explosion or a waterfall. With these settings in place, you now have 3D audio that adjusts based on the player's position in the game world. If you found this guide helpful, please give it a thumbs up and consider subscribing for more Unity tutorials. In the next video, we'll be adding sound effects to player actions. Thank you for watching, and I'll see you in the next one.